Suppose you select, without looking, 2 marbles from a bag containing 4 red marbles and 10 green marbles. What is the probability of selecting, without replacement, 2 red marbles? Simplify your results. Alright, so we've got a probability question here. 4 red marbles, 10 green marbles, so we have a total of 14 marbles. And we're going to select at random 2, and we want them to both, or we want to find the probability of them both being red. Alright, so for the first pool, I need a red one, so there's 4 marbles that make that happen. Out of, on your first pool, there's going to be 14 marbles possible. So probability of getting a red on the first draw is 4 out of 14. Now this particular question says without replacement, so that means we're not going to put the marble back in. So on the second draw, there's still going to be 14, or I'm sorry, 13, because we're not replacing it. We're not putting it back in. So we already took out the 1, so now there's 13 left. And not only that, but if the first draw took a red marble, then there's only 3 to get in your second draw. Okay, so draw 1, draw 2. Okay, so the first time you have a 4 out of 14 chance, because there's 4 red out of 14, and your second time there's a 3 out of 13 chance, because there's 13 marbles left, 3 red ones left. And in this case, the AND is multiplication. So 4 14ths times 3 13ths. Let's use our calculator for that, because we're going to have to simplify it anyway. 4 14ths times 3 13ths. Notice I went back and added some parentheses there to make sure it follows order of operations correctly. So if we rounded, that's about a 7% chance. Look at our choices. None of them are listed as percents. They're listed as a fraction still. So hitting math, enter, enter. Should change that back to a fraction for us. And not just any fraction, but the reduced fraction. And 6/91 was choice C. The answer to number 9 should be C.